In part A, the graph of y equals x squared plus 3 is vertically translated so it passes through the point 2, 10. Write the equation of the applied transformation. Solve graphically first, then solve algebraically. Begin by drawing the graph of y equals x squared plus 3. When the graph is vertically translated, it passes through the point 2, 10. Draw a dot at this location. By inspection, we can see that this point is 3 units above the corresponding point on the original graph. The graph must be vertically translated 3 units up to reach the point. The equation of the transformation is y equals f of x plus 3. Now we'll find the transformation equation algebraically. It's important to know how to do this because you may not always have a graph to look at. We know that we are applying a vertical translation to the graph, so begin with y equals f of x plus k. The point 2, 10 exists on the transformed graph. Plug in 2 for x and 10 for y. We need to evaluate f at 2 before we can continue with our algebraic solution. Use 2 as the input for the original function, f of x equals x squared plus 3. This will return a value of 7. Replace f at 2 with 7. Now solve for k. Subtract 7 from both sides of the equation to get k equals 3. Since a transformation equation is y equals f of x plus k, and we know that k equals 3, the equation of the vertical translation is y equals f of x plus 3. This is the same result we obtained using a graphical solution earlier. In part B, the graph of y equals x plus 2 squared is horizontally translated so it passes through the point 6, 9. Write the equation of the applied transformation. Solve graphically first, then solve algebraically. Begin by drawing the graph of y equals x plus 2 squared. When the graph is horizontally translated, it passes through the point 6, 9. Draw a dot at this location. By inspection, we can see that this point is 5 units to the right of the corresponding point on the original graph. The graph must be horizontally translated 5 units right to reach the point. The equation of the transformation is y equals f of x minus 5. A second answer is possible if we keep moving the graph to the right. If we translate the graph horizontally another 6 units, or 11 units in total, we pass through 6, 9 a second time. The equation of this transformation is y equals f of x minus 11. Now we'll find the transformation equation algebraically. We know that we are applying a horizontal translation to the graph, so begin with y equals f of x minus h. The point 6, 9 exists on the transformed graph. Plug in 6 for x and 9 for y. We need to evaluate f at 6 minus h before we can continue with our algebraic solution. Use 6 minus h as the input for the original function, f of x equals x plus 2 squared. This returns the expression 8 minus h squared. In our algebraic steps, replace f at 6 minus h with 8 minus h squared. Take the square root of each side so we can solve for the unknown. The square root of 9 is plus minus 3. Rearrange the equation to isolate h. The two possible values for h are 5 or 11. Since the transformation equation is y equals f of x minus h, and we know that h equals 5 or 11, there are two possible equations for the horizontal translation: y equals f of x minus 5 or y equals f of x minus 11. This is the same result we obtained using a graphical solution earlier.